All right, so I will get those quizzes graded back to you tomorrow. So we'll go ahead and have the opportunity to have a few questions on them. So there's still two things we got left on the agenda for today. One, I want to go ahead and take a look at any questions you might have on solving quadratics by factoring. Okay, I went ahead and gave this to you, I believe, Thursday, I believe was when I gave it to you last week. Okay. But did anybody have any questions? Remember, we were looking at greatest common factor, difference of squares. We were looking at trinomials. Okay. We were using the zero product property. Did we want to do a few just for a refresher? Okay. Let's start with number one. Now, remember, if you're going to factor, you want everything equal to 0. So x squared minus 4x, do we have a GCF? What is it? X. So if I factor out an x, that's going to leave me x minus 4 is equal to 0. So number one was simply a greatest common factor. Now, what we want to do with the parts in that product, we want to set them equal to 0. So first, x equals 0, that's one of my solutions. If x minus 4 is equal to 0, well then x equals 4. So my two solutions, I'm going to go ahead and write those in a solution set. Okay. Now remember, what are these numbers representing? If I were to look at a graph of x squared minus 4x, what are 0 and 4 going to represent? The zeros, the x-intercepts. This is where it's crossing the x-axis. Yes. So we already know a lot of things about quadratics now. We can go ahead and find the vertex. We know that because the leading coefficient is positive, okay, we know that this would be opening up. So let's say here's 0, here's a positive 4. So we don't know where the vertex is, but that's what we're finding here. We're finding where the graph crosses the x-axis. Okay. Let's see here. How about number 3? X squared minus 36 equals 0. Well, that is no GCF. But what kind of binomial is it? It's a difference of squares. Remember, a squared minus b squared, it breaks into groups that look like a plus b, a minus b. What do we call those? Conjugates. There we go. So what would my conjugate form for this be? X minus 6, x plus 6. We just take the square root of each of my terms. Okay. Once you've got it factored, then you use the zero product property. If x minus 6 equals 0, x equals 6. If x plus 6 equals 0, x equals negative 6. So I can go ahead and say this is plus and minus 6. Okay. Let's try one more. Let's go to number 5. So this is a trinomial. It's a simple trinomial, so we don't have to use the my father method. What two numbers would multiply to give me 27, but those same two numbers would add to give me 12? 9 and 3. So I would factor this by saying x plus 3 times x plus 9 is equal to 0. And just like the previous ones, once you've got it factored, I set each part equal to what? Equal to 0. So if x plus 3 equals 0, x equals negative 3. If x plus 9 equals 0, x equals negative 9. Okay, remember, for factoring, you want everything to one side. You want it equal to 0. All right, so that's what we were talking about at the end of last week. Okay, so were there any specific questions on that? Okay, fantastic. Well, was anybody ready to turn that in? Okay, sounds good. Okay, so hang on to it. I would definitely keep it because next week, early next week, I'm thinking probably Tuesday is when it's going to happen. We're going to have a quiz over solving quadratic equations. So it's going to be factoring, completing the square, and quadratic formula. We'll just kind of combine all of those into one. Okay, but that'll be on the website, and I'll talk more about it later. So let's go ahead and turn our attention to the other papers that you picked up today. Now, these are the three methods I just mentioned, how we're going to go ahead and solve quadratic equations. We've already done the factoring. Okay, and now we're about to start completing the square. We'll finish this up tomorrow. The assignment's going to be due on Wednesday, so that gives you a couple of days to go ahead and take a look at that. Remember, the key is already posted. Okay, and then later in the week, we'll talk about the quadratic formula. Here's the thing about our strategies. Okay, factoring is great. Okay, completing the square is typically the one that most students do not want to use. And quadratic formula is pretty efficient. It's pretty fast. But out of all three of these, myself personally, it doesn't matter to me which one you use. Okay, if I solve a quadratic equation by factoring, completing the square, and quadratic formula, I'm going to get the same answer every time. The only strategy that's not guaranteed to work every time is factoring. Because not every equation you come across is going to be factorable. But that doesn't mean it doesn't have solutions. Okay? That's why I have the 100% by completing the square and the quadratic formula. If you choose to work with one of those strategies, that will work every single time. Okay? So I'm going to leave it up to you folks. So especially if it says solve by completing the square, and you're like, I don't care for completing the square. Okay. Can you factor it or use quadratic formula? All I'm interested in is, can you find those solutions? Okay, so let's kind of get a warm-up real fast. Now, I've mentioned perfect square trinomials before, but let's see what we can do here. It says solve the equations below by factoring and using the square root property. Okay, so you see on the left we have x squared plus 14x plus 49 equals 4. So just focus on the left side of this. Okay, just right here. Forget about that 4 for a second. Are there two numbers that'll multiply to give me 49, but also add to give me 14? What are they? 7 and 7. So I'm going to go ahead and factor this. This is going to be x plus 7 times x plus 7 is equal to 4. Okay. What I've got highlighted right here, that's what's called a perfect square trinomial. If when you factor it, the two groups are identical, that's a perfect square trinomial. But let me ask you, instead of saying x plus 7 times x plus 7, couldn't I just go ahead and say, if this will let me do it, x plus 7 quantity squared? Because doesn't the square mean to take the base times itself? Okay. So I'm going to set this equal to 4. Well, let's say I were trying to solve this for x. How do I get rid of the square? We're going to take the square root. But whatever I do to one side, I got to do to the other. So a square and a square root are inverses. They're going to cancel. So x plus 7 is equal to 2. There's only one thing. When you're solving an equation and you take an even root, you got to put plus or minus in front of that value. Okay. So what I'm going to do is break this apart. One equation is going to be x plus 7 equals your positive 2. The other one is going to be x plus 7 equals your negative 2. And then we just go ahead and solve. What's a 2 minus 7? Negative 5. And then negative 2 minus 7. Negative 9. Okay. So if I were to go ahead and plug those back in, those are my solutions. They make it a true statement. Okay, that's what we're going for. Okay. Yeah.
Can we put them inside
The squiggly brackets?
Yeah.
Absolutely. Okay. Cool, cool, cool. Now that we've seen one of these, let's go ahead. Let's try this other one. X squared minus 6x plus 9 equals 20. Okay, so let's focus on just this guy right here. Okay, what two numbers will multiply to give me 9 but add to give me a negative 6? Negative 3 and negative 3. There we go. So x minus 3 times x minus 3 is equal to 20. So this trinomial right here, what do we call it? Because both groups were identical when I factored it. Perfect square trinomial. That's what we're referring to when we say perfect square trinomial. Now, just like we did before, I'm going to rewrite this as x minus 3 squared. And kind of use this other one as a template. I'm still going to take the square root. Okay. There's only one difference. 20 is not a perfect square, and that's okay. All right. These are still going to cancel. X minus 3 equals, let's rewrite that 20. If it's not a perfect square, we want to simplify it. We don't want to get a decimal answer. What's the largest perfect square that will evenly divide 20? 4. In fact, 4 times what? 5. Now, I still took the square root, so I'm missing something. What do you think I'm still going to put in front here? Plus and minus. Okay. But here's the thing. X minus 3 should equal plus and minus. Well, I can take the square root of 4. That's a 2. But I can't take the square root of 5 without getting a decimal. So it has to stay inside as the new radicand. Okay, we're just simplifying the radical. So I'm going to go ahead and move the 3 over. So x equals 3 plus or minus 2 square root of 5. So we are going to start getting into those answers where we're going to have radical expressions, and that's okay. That's perfectly fine. We're not going to take a decimal in those. Does anybody want me to, we won't go through another problem like that, but give you another square root that doesn't simplify completely? Okay. Let's say if I were to give you something like, how about the square root of 32? So think about your perfect squares. So you got 1, 4, 9, 16, 25, 36, ... What's the largest perfect square that'll evenly divide it? 16. 16 times what? There we go. 16 times 2 is still 32, but see, I can take the square root of 16. So that would be 4. The 2 has to stay inside. Is that making sense? Okay. We feel we're good, or we want another one? Another one? Sure. Okay. Let's do one more of these. Okie dokie. How about, let's say you were to get the square root of, thinking ahead, the square root of 50. Okay, so think about your perfect squares. Remember, hopefully we're comfortable with those up to at least 10. What's the largest perfect square that'll evenly divide this one? 25. So I'm going to rewrite that as 25 times 2. So what's my reduced answer? 5 square root of 2. There you go. That's pretty radical, right? Yeah, okay. All right. Now, this idea right here with the perfect square trinomial, that's how we're going to go ahead and solve quadratics in this particular lesson. Okay, so you got these steps right here. Okay. Now, here's how you want to start. You remember when you're factoring, it has to equal 0, right? Not with completing the square. You want it to equal your constant. You want the squared term and your x term to be isolated. You want it equal to your value, no variable. Okay. So what you're going to do, you see this right here? B divided by 2 squared. That is actually what we're talking about when we say we complete the square. Okay. Now, I'll go ahead and let you read through that. I don't want to sit here and read it verbatim. Let's just get to an example, and I'll show you how we do this. Okay. So I've got 3. It says x squared minus 18x plus 56 equals 0. Dokey. All right. First thing, I got to make sure it equals your constant. Now, if I were going to factor it, I'd leave it exactly as is. Okay. So I'm going to go ahead and rewrite this as x squared. What the heck? Oh, it's on a ooh, that's kind of cool. I accidentally chose calligraphic pen, if I can say that, instead of a normal pen. Yeah, I'm going to try that. Minus 18. Oh, that's awesome. Equals a negative 56. Wow. That looks really cool. I got to admit. Okay. Now, you'll notice I left a little bit of space between the x term and the equals because this is where we're going to go ahead and complete the square. Remember, that b that we're talking about, b divided by 2 squared, b is still your linear coefficient. Okay. So what I'm going to have to do is just plug it in. So b is negative 18. So a negative 18 divided by 2 squared. So what's a negative 18 divided by 2? So that's a negative 9. And what's a negative 9 squared? 81. Okay. All right. That's why I left a little bit of space here, because I knew I was going to complete the square. So I'm going to put an 81 here, but remember your number one rule of equations. Whatever you do to one side, you got to do it to the other. So if I add 81 here, I'm going to add 81 here. Okay. Is everybody okay? Now, let's clean this up a little bit. So x squared minus 18x plus 81 is equal to, I need a negative 56 plus 81. Okay, that's going to give me 25. Now, you see what I have right now? This is exactly what we were solving in numbers 1 and 2. This part right here, let me go ahead and highlight this. That is now a perfect square trinomial. Every time you complete the square, you create yourself a perfect square trinomial. What two numbers will multiply to give me 81, but also add to give me negative 18? Yeah. So what do you think? Should I stick with the calligraphy pen? Or? Okay, I just want to make sure. Okay, so I'm digging it. Okay. All right, so this is x minus 9 times x minus 9 is equal to 25. So now I'm going to do exactly what we were doing at the top of the page. This is x minus 9 squared equals 25. Okay, because that's still x minus 9 times x minus 9, right? But how do I get rid of the square? Take the square root. So that's going to give me x minus 9, after those cancel, equals, now the square root of 25 is 5, but what type of 5? And what did I put up front there? Plus and minus. Okay. So let's see, x minus 9 is equal to a positive 5, or x minus 9 is equal to a negative 5. Okay, so if I add 9, what's a 5 plus 9? 9 plus 5? 14. There's my first solution. If I add 9, what's a negative 5 plus 9? Okay, that'd be a positive 4. Okay. So I'm going to go ahead and say 14. Oops. And 4. There you go. This is what we call completing the square. It's just another way to go ahead and solve what we're looking for here. Questions? Okay. There we go. Well, at least I was able to introduce that. I was really hoping I'd be able to get away with another one. Okay. So I'll tell you what, we got less than 5 minutes left. So why don't we go ahead and stop there? We'll come back tomorrow and we'll go ahead and pick up number 4 after we talk about the quiz. Okay. Don't lose the notes, please. Hang on to those. Okay.